In this problem, we are given a singly linked list and we have to check whether the linked list, the nodes represented by the linked list, form a palindrome or not. So in the case of palindrome, all the numbers, if you read from left or right, it should come to be same. For example, in this case, we have 1, 2, 2, 1. So you compare the first and last, they are same. Second and second last, same. So whether you read from this side or this side, it will be same. 1, 2, 2, 1. Now read from this side. It can be even length, it can be odd length. And you are given, of course, in the case of singly linked list, as usual, you will be given just the pointer to the first node, which is called head node. So we have to return whether this is a palindrome or not. So true or false. Now let's see how we can do it. So let's say we have a linked list 1, 2, 3, 4, or let's take a palindrome. So let's make it 2 and let's make it 1. So this is a palindrome. So what we can do if we are given a linked list, how to compare if it's a palindrome or not. So depending on whether it's odd or even. So if it's even, then the mid will be lying here between two numbers. So this half in this direction should be same as this half in the other direction, or the other way around, in this direction and this direction. And if it's odd length, for example 1, 2, 3, 2, 1. In this case, again, whether you read from this left to right or right to left, it should be same. So this central one does not make a difference. It can be any value because it will lie in the middle whether you read from left to right or right to left. Let's write it from right to left. So 1 is the last element, so it will come first, then 2, then 3, then 2, then 1. So middle one remains same, so it's irrelevant. We never compare the middle element. So there are two cases, odd, even. So let's see. So how we can do it? How can we compare first and last? It's not very simple. It's not a vector or any other data structure. It's a linked list. For fetching any value, you have to iterate just in one direction. You cannot go back. So the idea here is that we have to compare first half and second half. So left part, right part. And the direction of comparison for left and right should be opposite, because we are comparing first against last, then second against second last. So in left part we are moving from left to right, in the right part we are moving from right to left, or vice versa. Both will work. So you compare the middle elements, the mid two elements, they are same, then next one, and so on. So what we will do, if we have two pointers, one pointer at the first element and one pointer at the first element of second half, then we cannot compare. This comparison is not allowed. If we are moving from left to right in the right half, we have to move from right to left in the left half. So you can see an idea that we can reverse the first part. So reverse the first part, then we will have 2, 1. And the right part, leave it as it is, 2, 1. Now we can have two pointers pointing to the first element of reversed left part and non-reversed right part. And now just increase both the pointers one by one and keep comparing. And at any point of time, if the values mismatch, you return false. And if you do not encounter such situation and you reach the end of both the lists, you return true. Only thing is that while writing the code, you should take care of this scenario, odd and even. So it's very simple. If you know how to reverse a linked list, it should be very easy for you. So the idea is that if we have a linked list A, B, C, D, and we have to reverse it. So we keep one current element and one previous. Previous is initially pointing to null, current is pointing to head, and next is pointing here. So what we do in a loop, while we reach the end of the list, we make currents next to previous. So whatever is the current, it's next this pointer now pointing to here, and this is gone. And then After doing this, we move previous here, current here, and next here. Again, so previous is current, current is next, and next is its next. And we keep on doing this. And again, we will do the same thing. Current's next is previous. So next of B will be A. And then again, we will move all these pointers to the right. And finally, D will point to C, C will point to D, and there will be nothing left. So next will become null. So this is how we reverse the linked list. And I am following the iterative version. You can also look into recursive version how to do it. So once you are familiar with this part, so this is the main part that we will do, and we will do it for first half only. And you know the reason why. And only one special case would be taken for even and odd length. So let's write the code. We will see here an example of odd and even. So first let's take an example of even. So we have 1, 2, 2, 1. And of course its next is null. So how can we reverse the first part? So you remember the notion of slow and fast pointers. So slow pointer we increase by 1 step, fast by 2 steps. So when fast reaches the end, slow will be in the middle, plus or minus 1 depending on odd and even. So we will have 2 pointers, slow pointing to head, fast pointing to head. And here you see the notion of current and previous. We have to reverse the first half. So previous, as usual, let's keep here pointing to null. Current, let's keep here at the first element. Now we follow the same thing, this loop. So you can add a base case. If head is null or head's next is null, that is just one element or 0 element, then return true. So let's forget the base case and come to a generic case. So we will have a loop after initializing these 4 pointers, while fast and fast next both are valid. Then we run this loop of reversing it. So when will the fast or its next will become null? Fast reaches either here or here. In that case, slow will be somewhere in the middle. So we would have reversed half of the list by that time, and we can stop there, and then we can do the comparison. So current is equal to slow. It's already slow for the first iteration, but we are writing a generic code. Slow is slow next. Fast will be fast next, and current's next will be previous. This is where we are doing the reversal, and then previous takes the value of whatever it was, current was there. So this is how we do it, and this will stop depending on odd or even. So let's run through it. So these are here, all slow, fast and current at 1. Then fast and its next are valid. So we do current is here at the first point, and then slow comes here. Slow is now pointing to 2. Fast is pointing to its next, that is here at the 2, second 2 here. And then current's next is previous. So this is gone, and previous comes where current was. So this is the state. So 1 is here, its next is null. Then we have 2, 2, 1, 5 or null. So this part is same, the second part. And previous is pointing to 1. Fast is pointing to second 2. Slow is pointing to first 2. So again, fast is valid, its next is valid. So this loop will execute again. So current comes here at the slow. Slow moves here. Fast moves by 2 steps. So now fast is null. So clearly this loop will end after this processing. And current's next is previous. So next of first 2 is 1. So let me rewrite it. 2, its next is 1. Its next is null. and previous will point to the second 2. And now this loop will end. So now we have 2 linked lists and we have to compare starting from first for both. Sorry, P will point to the first 2. This current was pointing to first 2, or it should be C rather. So previous is here and slow will be here because we advance slow by 1 step. So now we will compare both P and S. So P dot value should be same as S dot value. S is slow. And then P equal to P next, S equal to S next. And at any point of time, if this is not equal, we return false. And when this loop ends, that is when P or S becomes null, then we exit out of this loop and then we return true. Now for odd case, what is the extra condition needed? So again, this same code. Let's take 1, 2, 3, 2, 1. So fast is slow and current, all 3 here. Previous is pointing to null. So all 3 are valid. So we make this point to null. Slow comes here, fast comes here. Previous comes here. Again, fast and its next is valid. So we run through this loop, that is current becomes slow. So current is 2 now. And then what we do? Slow and fast we increment. So slow, fast. And then current's next is previous. So this 2 is now pointing to 1. This is gone. And then previous is current. So now previous is pointing to this 2. And now this loop will not continue since its next is null, next of fast. So it stops here. So what is the state? We have 2, 1, then empty. So remember that if we have odd number of elements, we don't compare the middle one. It does not make a difference. This middle element, like if we have 1, 2, 3, 2, 1, any value can be in the middle. So no need to compare it. So this part is fine. And previous now is pointing to this 2, the head of this one. The same was the case when we had odd number of nodes. Previous was pointing to the head of reversed list. But there the slow was pointing to the first node of second half of linked list. But here that is not the case. Slow is pointing one element before it. So in this case we will add if F. So in the case of even length, F did become null, you see here. But in the case of odd length, F is valid, its next is null. So if F is there at the end of this loop, then we know that it's odd length. So in this case, S equal to S dot next. So this is just one extra line that needs to be added for odd case, and then it should work for all the cases. So this part was tricky so that you don't miss out on some cases. Now let's write the code for this. Hope you understood it well. If not, pause the video and do a few exercises yourself. Take a few examples, run through this. Now let's write the code for this. So this is the problem. First we will write the C++ code. So again, add a base case if you want, although it's handled in our generic code itself. Then we will have a few list node pointers. Slow equal to head. Fast is equal to head. Current, or you can write CURR to make it more clear. And previous, I'm writing short form. It's not a good practice to just keep it fast and simple. Now while fast and fast next, both pointers are valid. Current equal to slow, slow equal to slow next, and fast equal to fast next, next, and currents next equal to previous, and previous equal to current. I forgot to mention the time complexity, so clearly you see that we iterate through this list left to right, so, and we stop in the midway when fast reaches to the end. So we have taken O of n time here, and then we again compare the left and right parts. So again O of n, roughly you can see we compare the left and right parts one by one, and optionally you can reverse it back also if you want to restore the list to original state. So overall time it will be O of n and space O of 1. Since we are modifying the list itself, a simpler way would be to, if you are allowed to use space, you can keep a stack. Just iterate through this list and keep all the elements into the stack one by one. So the last one would be at the top, second last at the second, and then keep popping and again iterate through this list and keep comparing it. So that will also work, but that will require extra space. Now let's complete our code. And we needed one extra line for that odd length case. So if what we will do, slow equal to slow next, and then we have first half reversed, second half reversed. Previous is pointing to the head of first half, slow is pointing to the head of second half. So while P and P val equal to S val. And if this condition fails beforehand due to this second part, if it fails due to first part, that means we have reached till the end and we did not find this inequality. So we have to just return, check whether P is null or not. And the solution is accepted. The same thing you can do in Java and Python. Not much change is required. If you get the idea clear, it should be very simple to convert from one to other. So this is showing false, it should be true, so there is some mistake. Okay, so the mistake is here, not these things. So if p is null, then we return true. So I had wrongly written not equal to null. Now the same thing we can write in Python also. And the Java solution is accepted. And the Python solution is also accepted.